Well, good afternoon, ladies and gentlemen. Thank you very much for joining us this afternoon for this session, which is one of our sustainability conferences and is on the theme today of design for circular composite products, turning waste, recycling and reuse into opportunities. Now, we could talk about this subject probably for many hours, so in 40 minutes, we're going to try and give you some helpful introduction and input to what's going on and how you can get involved. My name is Malcolm Forsyth. I'm going to be trying to moderate this session. I'm the Sustainability Manager for the Composites UK Trade Association in the UK. And the first thing I'm going to do is I'm going to ask each of our panelists to introduce themselves and to talk about very briefly what their company or their organization does in this area of reuse, repurposing, recycling of composites. So if I could ask, first of all, Fraser Barnes to introduce himself.
Good afternoon, everybody. I'm Fraser Barnes, Chairman and CTO of Gen2 Carbon. We recycle carbon fiber into technical textiles, which are used largely in the composites industry.
And on to Giorgio.
Thanks. Good evening to all. I am Giorgio Bettetto. I'm in charge of R&D at GIS Recycling of Italy. We are mechanical recyclers of composite, industrial one. We transform composites in new material and new products through a patented mechanical process.
That's great. And Pirjo, would you like to introduce yourself?
I'm Pirjo Pietikäinen. I come from Finland. I represent here Finnish Plastics Industries Federation, and one of my responsibilities is to run its composite group. And here I'm presenting our composite waste recycling exercise from composite industry into utilization in cement clean process.
That's great, thank you. And Dan, would you like to introduce yourself?
Hi, I'm Dan Coughlin. I'm with Oak Ridge National Laboratory, leader of industrial collaborations. We have a center, manufacturing demonstration facility, and we have a major program in sustainable manufacturing, which includes composites, 3D printed sustainable materials, recycling, all facets of sustainable composite materials.
That's great. And finally, Jen, would you like to introduce yourself?
Hi, my name's Jen Hill. I'm from an SME called Longworth. We're an emerging tech company with a technology that we would like to think is the next generation of recycling technology for this industry, allowing the reclamation of long length, high grade, good quality fibre and the resins that go with them.
That's great, thank you very much. And as you can see, we have a panel drawn from a number of countries and from a number of different technologies and different ways of recovering value from composite products. And what we're going to try and do now is to draw out some of the opportunities and challenges that are faced by players in this activity. So Fraser, over to you first of all. Perhaps you can tell us about what you see as the biggest opportunity and the biggest challenge involved with carbon fiber recycling today.
Sure, thank you, Malcolm. I think one of the biggest opportunities that's in front of us in terms of carbon fiber recycling is making use of recycled carbon fiber materials in applications which use their functional properties. By that I mean their properties beyond their mechanical performance. And as we see the trend towards decarbonisation, there are many areas where carbon fiber today is used for its functional performance in clean energy applications. This, I think, is the biggest opportunity in front of us. In terms of the challenges, I think our challenge is creating the awareness of the right applications in which to use recycled carbon fibers. We shouldn't be trying to force fit them into applications. We should be using them where they're the right choice, the right solution for a particular need. And I think it's getting that awareness across the industry that's the key challenge for us today.
That's great, thank you very much. If I could move on to Giorgio, you're involved obviously with the reprocessing of and repurposing of composite waste into new products. Can you tell us what you see as the biggest opportunity and the biggest challenge involved with that type of processing?
The biggest opportunity is to open. We are we are making panels, products made from many kinds of composite. The biggest opportunity, particularly in this moment, is to reuse and recycle and obtain a product that may enlarge the composite use, because when you are using a composite, any kind of composite, you already have something that cut the emission. You have any kind of product in composite will last longer and require less maintenance respect any alternative. This alone is a big advantage. With the technologies that we are developing and we have developed, it's possible to enlarge application to even low-tech application. The biggest challenge is to convince the people that to think out of the boxes. Don't say, okay, we have always done it this way, because it's the bigger problem. Recycling products may be cheaper, competitive, and better respect alternatives that are not composites. Thanks.
That's great, thank you very much. And Perio, if we move on to you, you're involved with a big project to look at cement kiln co-processing as a way of treating composite waste in Finland. So can you perhaps talk to us about the opportunity that is and the challenge that you're finding as you're trying to implement that?
Yes, firstly, I see the opportunities because we already have the technology exist and it's running, and it has been demonstrated to be very good in that way that 100% of the composite waste is used in that process, part of it as energy and the other one as a raw material in cement kiln. Speaking about the challenges, I think one of the biggest one is how to organize the logistics. So inside a composite company, it's not a problem, but then now they have some systems for landfill or incineration or whatever, but now there should be another kind of organization. So the composite waste has to be sorted in plant, then transported to some place. From there, in Finland, they are gathered in one place because there is only one factory that shreds the material. Then it has to be transported into the cement kiln factory. And as you might imagine that all the transportation means some costs, and maybe companies don't like them so much.
That's great. So we get a feel for some of the logistical challenges. And if we move on to Dan, obviously cement kiln co-processing is another of the options that's being pursued and developed in America on a bigger scale. Perhaps you can talk to us about some of the opportunities and challenges that cement kiln co-processing as a means of recycling composite waste is facing in the US today.
Well, first I want to thank the folks in Europe who helped us get up the learning curve on cement kiln, particularly the folks in Bremen area. As you might be aware, wind blades form the core material to get that system up and running. There's roughly 70,000 tons of wind blades that are being repowered in the United States. But even though that sounds like a lot, it's actually very small compared to cement production. So scale is an issue. Composites as an industry is fairly small compared to other industries. And so we face a similar problem in Finland in that the supply chain is a big challenge. But the good news is the composites that are out there that are not yet being recycled have a much higher biogenic content, which does help the cement industry, which is roughly 8% of global CO2 emissions for industry. So in terms of the opportunity that's out there, there's a lot more composites that can be recycled, but also the cement kiln should be seen as a backstop and not the best or first solution for reusing composites. There should be reuse, there should be repurposing, remanufacturing, other forms of capturing value before you get to the cement kiln process.
That's great. Thanks, Dan, for helping us just understand a bit of a hierarchy there. And if I move on to Jen, you're obviously developing and bringing to market a very different technology, perhaps one for the future. So can you talk us through what you see as the opportunity and what is the challenge in terms of bringing that technology to a commercial scale?
Yeah, I think the opportunities are many. So without going into too great a detail, you could go right from the fact that as an industry globally, we could achieve zero waste from composites relatively fast, not in the future, but now. I think for each individual company within composites, there's an opportunity to become net zero practically overnight. There's an opportunity, more importantly, to change from being a waste producer to a producer of high-grade, usable, recycled carbon fibre and glass fibre. You would essentially become an advanced materials producer for free of charge materials, which is difficult to wrap people's brains around. I think more importantly for the entire industry, the opportunity at the moment is the exciting one that carbon fibre has historically been high cost, short supply, very much in demand. We can now potentially, very realistically, reuse every carbon fibre manufactured multiple times before it ends up getting to the end of its lives. I think the challenges with that are that as an industry, quite rightly, everybody wants to recycle rather than waste. Everybody in the room would say they'd rather not send anything to waste. But where do you expect that recyclate to be used if you won't do it within your own businesses? If you're creating very low cost, very high performance material, why aren't you using it as well? So that's the main challenge for new technologies to break through.
That's great, and perhaps the audience might like to begin to think about, if you're also producing waste, what are you going to do to start being part of the solution and using recycled materials rather than leaving it to somebody else? What role could you play? What parts could you make in recycled fibres, for example? Because until there's a big uptake in that, it's going to be a challenge to really move some of the technologies forward. So I throw that thought out to you at this stage, just to be thinking about what role could you play in helping to draw market demand, upwards. I think coming back to the panel, what I wanted to ask the panelists now was to think about, what needs to change to really see an increase in the amount of reprocessing, recycling, and use of recyclate. And also, what role do you think there is for governments, for legislators, to help with that process? So I'm going to just let the panelists sort of expand a little bit on that, and let's see then what questions that hopefully prompts from the audience. So, Fraser, if I start with you, what needs to change to increase the use of recycled carbon fibre, and what legislative or regulatory change would you like to see to help that?
Yeah, so in terms of increasing the rate of recycling, it's down to identifying the right applications for the material. So having an open mind when you're considering how to achieve a particular part or component, where could recycled materials be used in that? And it's about that awareness and that getting people to think, could I do this with a recycled material? That creates the market. In terms of regulation or legislation, specifically around should we regulate to increase the use of recycled materials, our view would be no. We think this should be market driven, and we think that if we regulate to try and force the use of these materials, they'll end up being used in the wrong applications, we'll be greenwashing, so we won't be doing it for the right reasons. So our view, it's around building market awareness, getting people to think about where they can use recycled products, and if we do that, the market will absorb all the waste that we can produce. But legislation is something we'd stay away from at the moment.
Okay, so there's a view that you might like to come back on, very much looking to the market to drive demand and generate the pool for recycled materials. So Giorgio, how about you? What do you think needs to change to increase the amount of reprocessing, and what role for government?
Yes, it will need, on one side, it will need more investment. Our technology, this recycling technology are already established, but it's much easier to find financement for any kind of startup in digital world, even with very low significant respect there. The second is the marketing push, marketing work, selling material, make understand what is possible to do, what are the advantages, and every day try to find new applications. From government part, we would like to have sort of the establishment of a common ground. So it should be taken in account what are the impacts of any kind of products, and on this make evaluation if a material, a product is sustainable or not. I see a lot of greenwashing and a lot of things that is really hard to understand, even like selling recycled material. This is with recycled content from China. Only the transport makes its high impact.
And is there anything from a legislative point of view you'd like to see governments doing to help to drive the growth of the use of recycled materials and the like?
Yes, they need to tax the exact impact of the product. That means also re-equilibrating, for example, the import versus the export, because currently we have understand that long-range transport is unsustainable only when we have 500 ships blocked in Shanghai. But this is already a problem before. This is simple because from a tax point of view, it's much cheaper to buy abroad and use virgin material, respect recycling in Europe or USA and producing local. This is something that needs to be re-equilibrated.
That's great, and I think you've helpfully highlighted one of the challenges that the industry faces, which is around raw material supply, and yet we have, within the continent of Europe, hundreds of thousands of tons of waste composite, which could be recovered, and raw materials could be recovered from, which would greatly alleviate some of the supply chain pressures that are being felt all around the world on a whole variety of raw materials for composites. So using the waste that we've already got better and recovering raw materials from it is a key part of growing the composites industry in Europe going forward. So Pirjo, maybe if I could come to you and just ask you the same question. You know, what sort of change, what one change would help to drive the recycling of composites more, and what could governments play in helping that process?
To be very short, I would like to say that landfill ban is a very strong tool here. Most probably we need other rules and bans, but I hope the composite industry will be strong together to strongly affect whatever it comes to the regulation of using of composite waste and what to do with it.
Okay, thank you. That was very short and to the point. So Dan, over to you. What change do you think would help to drive the increase of recycling, and what role might government play to bring about that effect?
Well, in the US, I rather doubt that they're going to ban landfills anytime soon. But the government could convene the entire composites industry right through to the end users, right through to the manufacturers, the OEMs, all up and down the supply chain, to look for opportunities to create market pull, look for those killer applications for recycled composite materials. The other role of government could be to help facilitate the development of specifications and development of the recycling supply chain, so that there's some place for the materials to get sorted and collected and then reused.
That's great. So, some help with logistics and the supply chain, really, but also particularly getting that market pool coming through more strongly that will drive the demand then and bring about those solutions.
Yeah, one other thing is that the government can use their considerable procurement opportunity to pull in applications for recycled composites. I lived through the wood industry's recycling of cellulose fibers. And it was in the US, it was really that market pull, the specifications from the federal government for recycled content that really drove a lot of innovation in that area.
So clearly governments can play a role just purely by starting to buy or insist on more recycled content in products, and that will help to generate some of that market pull we're talking about. Great, and Jen, on to you. What change would you like to see to drive up the increase of recycling, and what role might government take in bringing about that increase?
I'm going to be even more brief, I think, because I believe there's an element in what each of my colleagues have said. I do think probably to incentivise rather than to punish, and thank goodness for all of us, I'm not a politician, but I would suggest that a really, really big change could be brought about by a policy and legislation around traceability is a massive thing, because if we can't recycle 100% of our composites, then we're failing.
Okay, so you'd like to see something around traceability to really help kind of, drive that process on a bit further. Okay, well, you've heard from our speakers. They've all been commendably brief. There's much more that they could have said and would like to say, but what we'd like to do now is actually throw the opportunity open to you to raise your questions. And no question is out of bounds, I think. And I'll try to direct the questions to the most relevant person on the panel to answer it. So I think we have 2 roving microphones in the vicinity of the floor. So if you'd like to ask a question, can you put your hand up? And so we'll try and give an opportunity to answer all the questions that we have. And I know it can be a little bit intimidating to be first, but you at least will get your question answered. So great, we've got a hand up here to the left. So don't be shy. We've got somebody willing to get us started over here. I'm hoping a microphone is going to come to you fairly quickly. Yep, there's one coming from the back. And while this question is being asked and answered, do think about any questions you've got that you would like to ask. So if you could introduce yourself and then give us your question.
Hello, good afternoon. I'm Gabriel Fais. I'm the CEO of Polyloop. We are a startup based in south of France. We have a technology of selective dissolution to recycle composite. My question is, do you think that other solutions that traditional mechanical recycling could face the challenge of recycling composite multi-layer products? And for you, what are the promising technologies to recycle composite-based products?
Oh, that's great, thank you. So the question really was about how well a mechanical process could cope with a multi-layer composite, and what are the options that are available. So I think I'll give each of the panelists a chance to give a comment on that. I'm sure what we'll see is there are multiple ways in which composites can be reprocessed or recycled. But Fraser, perhaps you'd be brave enough to start us off, and we'll see where the conversation takes us.
Sure. So I think to very quickly answer your question, the answer is there is promise for other techniques. I mean, we're now implementing our 2nd generation pyrolysis process. We learned a lot in 10 years of operating the first process. We learned what worked well, what we'd like to improve, and the 2nd generation process drops down our energy use significantly compared with what we did before. Equally, we keep a close eye on chemical recycling technologies. And again, I think there's a lot of room for developing those technologies and to get them to the point where they become something which helps us with our recycling. So yeah, I think that nobody can sit here and say we have the right technology today, because I think we're continuing to learn as the industry grows. Where we are in 5 years' time, I think, is going to be very different to where we are today. I think chemical recycling techniques have a role to play in that. And I think there's an interaction between chemical recycling techniques and resin chemistries which also have a role to play in that. So I think we're going to continue to see developments in this area.
That's great, thank you, Fraser. Giorgio, do you want to give a comment about the range of techniques and of processing composites?
I think that's sure it's that composites require several different kinds of composite recycling technology. We can't hope to have just one technology. in no kind of recycling currently in function. If we think wood or we think paper, we have just one technology and one product. With paper, you make cardboard, you make paper newspaper, you make a lot of different things. You make the tissue and so on. Nobody think, okay, I will just make the tissue. So it's necessary. I think there is a lot of potential development in other kind of technologies, particularly in dissolution, separation, pyrolysis. The problem is that one needs to work it's a very strong contact with the market to be sure to make something that makes sense from an industrial point of view, so needs to be sustainable from ecological point of view, but also economical point of view. We have, for example, the European Union has funded a lot of composite chemical recycling process, I think more than 12, but no one have converted in industrial process. I think that there is, for example, in this case of dissolution, we have, for example, a composite that is still a composite, but probably outside of this kind of aspect. For example, the alucobond, aluminium with PVC. That's probably the ideal product to be recycled that way.
Okay, so you see the need for many different processes to reflect the range of composite products.
Start from the bottom, start from the output.
Yeah. Okay. Perio, would you like to give a comment on that?
I totally agree with my colleagues that has presented the point of view that many technologies will be needed. There won't be only one. It depends on the application. It depends on what is going to be done with the material after the recycling process. So after 5 years, there will be a lot of happening here. I know that a lot of is already happening and a lot of is already ready, and we are just expecting the whole scale to be utilized.
Okay, that's great. Dan, would you like to give a comment?
There are a lot of technologies out there. You know, there's light solvolysis, there's pyrolysis, there's high voltage processing, there's steam-based, water-based. But probably the biggest leverage to get recycling more widely used is to design in the circularity, design in the sustainability, design in the reuse. And one thing we ought not forget is that composites last many times twice as long as other materials, especially metals. Well, if you think about what can we do to help the planet be more sustainable, is to convert more metals, more other materials to composites that last twice as long and therefore reduce the waste stream by 50%. So that's something else we can do to help circularity.
Yeah, and I think that is a really important point we've kind of made at the beginning and want to continue to make, that by using composite materials, we actually replace materials which need to be recycled much more frequently. Composite materials will last decades typically, and therefore the number of recycling loops that they may need to go through is much lower. But we still need to have good processes and technologies to do that. So Jen, do you want to give your thoughts on that question about recycling technologies and the role and place of different ones?
I think we're all agreed, really. If there was one winner, we'd already be doing it. We wouldn't be having this conversation. There's no one technology going to be a solution globally for every composite, for every material. I think certain technologies and applications are right for different life cycles, for different applications. It does depend very much on what you want to do with the output material, the recycler, as to what quality you might want to get it out of. It also depends on your carbon footprint. How important is sustainability to you in that decision-making process. I think there's certainly things that our technology will never be able to process, and so if that was the only technology we had available, we'd be scuppered. So I think there's a place for all of those technologies, but out of all those comments, Dan's is the one that stands out, that as an industry, if we start, we're design engineers, that's the job. So if we start designing it in, knowing that that's how you suspect that piece of aeroplane or whatever will be recycled, then you've already chosen the most optimum method for doing the job.
That's great. I think that point is one we definitely want to kind of land with you as an audience, that we need to design parts for recycling at the end of life. Do that consciously at the beginning in the material choice and the way the parts are put together. That's going to be critical for having a really effective recycling process at the end of life, whenever that point's reached. I hope that's given you some useful answers to your question. Thank you for asking it. Do we have any other questions? Please don't be shy. You won't be the first. Anyone else want to ask a question of the panel? I'm looking around hopefully for an arm raised, but oh yeah, we've got one. Thank you.
Thomas Kubitz from a company Lacova in Germany. With thermoplastic thermoformers, it's a slightly different, it's not a composite technology, but we have a dedicated recycling loop. Our own material comes back at the end of life, it's shredded, re-extruded into sheets which are reused. And it's a perfect and a complete circuit. My question is, for the different composite recycling processes, are all of them complete, or do some of them have residual chemical leftovers for which are a problem in regards to things like breach and so on?
Okay, that's great. I think that's a very valid question, because obviously with thermoplastics, there is the opportunity for a complete closed loop and recovery fully of value and of properties. It is more difficult with composites, and we all know that. So again, shall I just go along quickly? Maybe just a quick word on this. Fraser, would you like to go first?
Sure. So with the pyrolysis process, we generate pyrolysis gas. The pyrolysis gas can be used as an energy source to provide the energy that's needed to run the process. So yeah, we apart from the fiber, we do have a waste stream of the pyrolysis gas, but we reuse that to generate power. So there's nothing which we have to worry about from a reach perspective. We do need to worry about it from environmental air quality. So we need to make sure the emissions that come from the final step in the process stay within the limits.
And do you want to say anything about the quality of the fibers in terms of what you get out at the end and how they compare with the input fiber?
Yeah, so typically with the pyrolysis processes, you're looking at a reduction in strength of 5 to 10% and no change in the modulus of the fibers. So once you've been through the optimization loop and you've set the process parameters, we retain a very high degree of the strength of the original fiber.
That's great, and I think that highlights that it is genuinely very difficult to regenerate fibers which have exactly the same properties as the input waste material fibers. That is one of the big challenges with composites, but that doesn't mean that there aren't plentiful markets for the recycled product. It's just a bit different to the virgin product that went in. Giorgio, do you want to add a comment?
Yes, thanks. First, very good that someone is trying to make a closed loop on thermoplastics. Is not always possible, also because in thermoplastic recycling, in waste plastic recycling, the market is open mostly for the so-called commodities, HDPE, LDPE, polypropylene. Already polypropylene charged with glass fiber polypropylene becomes harder to sell and harder to, because normally we have the problem that when you use a technopolymer, you have already calculated all for exploit at max the properties, and so when you are using a polymer that costs 10 euro kilo, you don't use a regreened one because it will weigh more than 1.5 and so on. Second, there is still a lot of opportunities also in several steps of recycling of production. For example, one of the things that we have seen is that with the recycling of glass fiber, it's possible to obtain a small fine fraction that could be really interesting as alternatives to mineral fillers. Again, the problem is that is something that someone needed to do, to test, to try at the industrial scale, and so are all the problems that you have to come out with a product that someone tests. But there are a lot of opportunities to be done, particularly in this moment with the tension on the supply chain.
Okay, thank you. Perio, do you want to add a comment to what's been already said?
I think that in this phase I rely on the comments of my colleague.
Thank you. Dan, do you want to add any thoughts?
Yeah, so definitely there are byproducts to many of the composites recycling processes, with the exception, so I'll be of two minds about cement kiln reprocessing. On the one hand, it should be a backstop. It should be the last refuge of the composite. It should be reused, remanufactured, more value captured. But, so I'll argue the other side, cement kiln is, as the folks in Bremen called it, the perfect recycling, because all the material is reused. You know, the silica and the other inorganics go to make the cement stronger, and the biogenics are used as fuel. So it's a complete recycle loop, and then once it becomes concrete, it can be recycled over and over again. So there is a complete use of the materials in that process. But again, I emphasize it should be the fourth, fifth, sixth step, maybe the 100th step in the process.
That's great, thank you. And Jen, any final thoughts on this question?
Pretty much what Dan said, with the slight addition that I would like to think that no matter which method you prefer or use, we're all constantly improving and striving to make it cleaner and greener. Our technology, for instance, was actually invented to do a green job. It was to do that reclamation job in a cleaner, greener way. However, we're now we've proven what it can do. We're working on the actual footprint of the unit itself to bring that LCA down. There's constant plans. There's 2 new patents pending, for instance, to make it potentially run off sustainable energy. That should be the case, irrelevant of solvolysis, hydrolysis, mechanical pyrolysis. It's irrelevant. We should all be looking at whatever that method is, and the fact that it brings sustainability to the industry using it isn't good enough. It should also be sustainable within itself.
That's great, thank you. There's some real thoughts in there. I think, in brief, to answer the question, you can have a closed loop, but it'll look different to the thermoplastics one. The end products will be different, but we can ensure that everything gets used. Unfortunately, our time is coming to an end, so I'm going to ask each of the panelists just to give us a kind of final message, a one-line final message about this whole area of reuse, reprocessing, and recycling to drive greater value. So Fraser, after you, just a quick one-liner to finish.
Yeah, keep an open mind about your material choices and where you can use recycled materials.
Keep an open mind. Think recycled before all the rest.
And be active, so analyze your own processes, take part in the discussion and find partners.
At Oak Ridge, we just did a project where we made composite tooling from partially renewable materials and demonstrated we could recycle that same tool. So I invite all of you to come visit us in Tennessee.
I would say stop comparing recycled composites to virgin composites. They're not the same, and in many cases they could be better.
That's great. So there's some final thoughts. A final thought from me would be to challenge you to think about where can you use recycled composite materials, because you're the ones who are going to produce the market pool, which will make it a much bigger reality for everyone going forward. So just finally from me, I want to thank our panelists. Thank you for coming. I hope you found it informative and useful. Thank you very much for your time today.
Why won't you speak? Where I happen to be, silent in the trees.